Today's session, we will be discussing very important topic, recursion. So this topic, we will see definition of recursion, what are the different types of recursions, and we will take a simple example of recursion and we will go with that, what is recursion. So what is recursion? Process of function calling itself. So the process of a function, there will be one particular function. It can be a user-defined function or it can be any inbuilt library function. When you call the function, for example, I'll write a main program. I'll be calling one function in that main program and I will write a definition of that function somewhere else in the part, and that function will be calling itself. Once I give an example, you will come to know this. The process of function calling itself is called recursion. How this recursion will work, I'll just show you one simple example for this. I'll write one function. For example, I'll write fact of n. I'll write a program for this. Somewhere in set of line, I'll be calling the same function, fact of n, some return statement and close this. So this is one set of function. This is a user defined function. Now this is fact of n. This is one function definition. Within the function definition, the function is calling itself. Now look here, when set of statements are executed, fact of n comes into picture. Again it will go back. It will start executing the same sentences. Again it will come here. Again it will go back. It will start executing. So this type of process of function calling itself is known as recursion. Recursion is a method of solving the problem where solution to a problem depends on the solution to a smaller instances of the same problem. Now look here, fact of n is there. I need to get, for example, I want to find out factorial of 4. 4 is nothing but 4 into 3 factorial. Again what? 4 into 3 into 2 factorial. Again it is 4 into 3 into 2 into 1 factorial. Again it is 4 into 3 into 2 into 1 into 0. Like that we will take. So that is, here the solution of this is depending on the instance of the solution of this 3 factorial. Again these two depends on the solution of 2 factorial. Again these three depend on the solution of 1 factorial. So thus a recursive function is a function where the solution of a problem depends on recursion is a method of solving a problem where solution to a problem depends on the solution to a smaller instances of the same problem. When you want to get the smaller solution from solution of main problem, it depends on the solution of smaller instances. We will be using recursion. Thus, a recursive function is a function that calls itself during the execution. So, the recursion refers to a process where function calls itself either directly or indirectly. So, recursion is nothing but a function which calls itself is known as recursion. So, when you come with recursion, there are two types of recursion, that is direct recursion and indirect recursion. What is this direct and indirect? We will go with this direct first. It refers to a process where a function calls itself directly. Now look this example, there is a function 1 like factorial, whichever I have written. This the function is calling itself directly. F1 function 1 is calling function 1. Same function which will be, it refers to a process where a function calls itself directly. Now for example, you take int factorial, int fact of int n, fact is calling again fact. Again, look here, this is one function. Fact is calling fact directly. This is direct function. Calling itself directly. Within that function, I'm returning the same function. That is known as direct recursion. When the function calls itself directly within that program, within that function, it is calling itself. As illustrated above, function 1 calls function C1. This is a type of calling itself is called direct recursion. And the recursion it takes place until the given condition is satisfied. Until this condition is satisfied, this function will be executed again and again till you get a proper output. Okay, so this is what a simple example factorial. So now we will go with indirect recursion. Look here, it refers to a process where function calls another function and that function calls another function and that will somewhere call the original function. Look here, function 1 is this function is calling this function. This function is calling this function and this function is calling back this function directly. That is indirectly, this function is calling this function is calling this, and finally this function is calling this. Function is calling some other function, but it is not itself. It is calling some another function. That is known as indirect function. This function will call this will call this. So this is known as indirect function. So properly, when we are writing a programs, we will be using, we will be using direct recursion to solve the problems. So when you have a recursion, we will consider two important cases, that is base case and general case. What is this base case? The case where for which the solution can be stated non-recursively. That is that this case is the this will be an ending case. This will be ending point. So you cannot call it again and again. Somewhere the recursion will stop. Recursion should stop. That is known as base case. With this base case only we can stop the recursions, or else it will keep on continue. It will go into infinite loop. Should stop. So that is base condition. Then recursive case or general case is case which the solution is expressed in terms of smaller version of itself. Okay, some smaller versions of function we will be calling again and again. That is known as general case. So these two are the very important cases that we consider in the recursion. We will go with this with the examples. Recursive algorithm. Solution that is expressed in terms of smaller instances and a base case. That is, we will use both base case and recursive case together in one program. That we will call it as a recursive algorithm. Okay, so recursion is calling a function calling itself is known as recursion, and in recursion you have two types, direct and indirect. When you have direct recursion, especially we will be going with base case and general case. So we will go with certain examples with this, especially I will solve factorial of a program recursively. Problems defined recursively. There are many problems whose solution can be defined recursively. Example is factorial. Now this factorial we will be having both, that is base case and the general case. Now look here, I will write this one. If n equals to 0, that is this is a stopping condition for me. If n equals to 0, this is a base condition. The first one is base condition, and this is one important thing. This will be stopping condition for a program. Then this second statement is general statement. Usually the recursive algorithms or recursive functions will be written in this way. One will be base condition and second will be general condition. So factorial of n is nothing but if n is equals to 0, we all know that 0 factorial is 1. So we have to stop somewhere where you will get 0. So 0 factorial is equals to 1, and then general case is calling function is n minus 1 into n factorial. You people already know this in mathematics. That is what, look here, 1 into 2 into 3 into n minus 1 into n. This is the general formula in mathematics we will be using. So that is what n factorial equals to n into n minus 1 factorial, where n is greater than 0. So this is recursive solution. This is one closed form solution. So now we will, with the help of this recursive, we will solve the factorial of n, and we will go with a simple code for this factorial. So now look here, I have to find out the factorial of 5. 5 is nothing but 5 into 4. 4 is nothing but 4 into 3. 3 into 2 factorial. 2 into 1 factorial. 1 into 0. Somewhere I should get this I should stop this. That is, this is stopping condition base case. So this base case comes here when you need to stop this in the program. So this is base case where now I will stop and I have to return this solution here to execute this. So 1 factorial is 0 factorial is 1. So 1 into 1. This is 1. So this solution will be written here. 2 into 1. So it is 2. This solution will be written here. 3 star 2. So this solution will be written here. That is 6. 4 star 6. And 4 6 are 24. So this solution will be written here. 5 star 24. And finally, this solution will come for the main general solution. This is what the factorial. So 5 factorial, look here. This is how from beginning we have to write a program from normal. This thing, the beginning number, we have to start the program and we have to end at the base condition. Once I get the answer from the base condition, it has to go back, return with the answers and go back, and finally you will get the answer. This is what normal any of the recursion will work. This is how the recursion. First we have to start with the general case, start executing the general cases until you reach the base case, and once you reach a base case, you will get the answer for that. You have to take that answer, go back, return. You have to follow the return steps, and finally you will get the answer to the normal proper solution to that problem. So this is what a simple example. Now we will go with the coding of factorial. As we already know, this is recursion. So I have written a coding of a factorial. Int fact of int n. If n is equals to 0, this you have already known. This is very important example. If n is equals to 0, return 1. This is the base condition. If n is equals to 0, I have to return 1. What I have to do? Else. I'm using if and else part. If, else. If this condition is true, it will execute this. If condition is false, it will come to the else part and it will execute else part. N into factorial of n minus 1. Look here. Now again what happens? N into, this is again a function. Again this function will go back here and again call itself. This will be executed again and again till this base condition is reached. This is what a recursion program. Now I'll write a full program and we will explain the logic of recursion in this. Now look here, this is the main program. This is the very important program. So this is a main program, and now with the main I am declaring a int n, that is how many numbers I have to find out the factorial. What is the number I need to find out the factorial? Int n. For example, I will take n is equals to 4. Okay, 4. Now scanf and n. Result is equals to factorial of n. Why this result? Because this result is from here. I am returning from here. I have written the value from here to here. Now look here, res equals to fact of n. This is function call. So this is function call. This is function call. Now when this function is called, it will directly go back to this factorial function. Now in this factorial, what you have? Int fact of int n. I have int 4. Now if n 4 is equals to 0, the condition is false. Now it will come here. Now this block will be called. I'll take it as a blocks now. So this block will be called. So now int 4. Now if this is n is equals to, that is 4 is equals to 0, false. It will come to else part, that is 4 into factorial of 4 minus 1, that is factorial of 3. Now there is no answer for factorial of 3. Again what is happening now? Look here, this function is calling itself. As soon as this function is encountered, again this will go back. Now again this program will be executed once again. Now what is the value of n? N is now what? N is equals to 3. Now again it will execute one more block. Look here. Now n is equals to 3. That is 3 is equals to 0. False. Now it will come to else part. Return. That is 3 into factorial of 3 minus 1. That is fact of 2. Did you get an answer here? No. Again what happens? Again call the function back. That is n is equals to 2 now. So 2 is equals to 0. False. Go to else part. This is one more block. This is how the factorial. This is how the recursion will work especially. So now 2 into factorial of 2 minus 1 is 1. Now again you have to call one more block. I will call one more block where n is equals to 1. 1 is equals to 0. False. Again go to else part. 1 into factorial of 0. Again this will call one more function. N is equals to 0 for me now. Again this block will be executed. This is what calling itself. 0 is equals to 0. Yes. Now look here down. The base condition is executed. If it is equals to 0, what happens? Return 1. 1 will be returned. Return 1. Now this return is entirely different from this return. Here whenever you write return, it is entirely different. Now I will return 1. The answer of 1 will go here. 1 into 1. So that is 1. Okay. This is what return I have. Return. Return statements are here. This is return. Okay. These are all return statements. Now again 1 into 1, 1. This will return here. The solution will come here. 2 cross 1 will get. That is equals to 2. Again this will go return here. This answer will be written here. 3 cross 2. That is equals to 6. Again this solution will come here. 4 cross 6. 4 6 are 24. Finally, this 24, whatever you have, that will be returned as an answer and that will come to this RES. Now, RES is equals to 24. Finally, you will print the result on the screen. This is how the recursion will work. So, this is what a simple example for recursion we have. We have still many recursive programs. That is, we have Fibonacci series. What is this Fibonacci number? Look here, when you add these two, even Fibonacci numbers are there which can be solved recursively. That is, add the previous number and the present number to get the next number. So 0 plus 1 is 1. 1 plus 2 is 3. So then 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. Like this. Adding last previous two numbers, we will get the next answer. This is known as Fibonacci. Even you can solve this using the recursion. So the general form for this recursion will be Fibonacci of n minus 1 plus n minus 2. That is what, look here. When I want to get this number, I have to minus this one and this one. I need to add this one. What is this? This is n minus 2 and this is n minus 1. So add n minus 1 plus n minus 2. You will get the next number. That is what Fibonacci. So Fibonacci series, and this is the general form. Using this equation, you can write a program and the base conditions. These are the base conditions. So Fibonacci of 0 is 0 and Fibonacci of 1 is 1. Look here, these two conditions will be the base conditions. 0 is 0 and 1 is 1. Based on this, you can write a simple program like this. If n is equals to 0, whatever I have given the base conditions, return n, else return fib of n minus 1 plus fib of n minus 2. This is the function, main function, and this is the void main, and this is the Fibonacci function, and here the function is called. Now look here, fib of n is called, it will go here and execute this again and again until you will get the answer, and finally you will print this on the screen. This is how recursion will work. So recursion is nothing but a function which is calling itself. Now I take this function, fib is calling itself, fib of n, fib of n. So function which calls itself is known as a recursive function. Thank you.